Welcome to Telegeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and my guest today is Khalid Raza, the founder and CEO of the Silicon Valley startup Graphiant. He's going to talk about their unique approach to network as a service. So we've talked about NaaS fairly often on the show, but I think something worth emphasizing is that NaaS is really a description of a way of selling networks that encompasses many different products or technologies, just any that allow you to sell networks as a service rather than companies building their own network that they own. So Khalid has a very deep history in networking and has often been at the center of really big changes over the past couple of decades. So as you'll hear in our interview, he was involved in some of the earliest large-scale MPLS deployments going back 20 plus years. And then seeing the limitations of MPLS, he went on to co-found Viptela, really kicking off the SD-WAN revolution. So this is a guest who really knows what to look for in changes in how enterprise networks are sold and set up. So in the interview, Khalid describes how enterprise networks have changed in the past few years and why that leads us to need a new approach beyond MPLS and SD-WAN. So we talk about why he founded Graphiant, what their approach to solving these modern network problems is, and how that is different from other NaaS providers and WAN services in the current market, and how he might work together with those solutions. Of course, we touch on security a little bit because you can't have a conversation in networking now without that perspective. And we look forward at how Khalid, who has been at the center of so many big networking revolutions, sees enterprise networks developing in the years to come. So listen through to this one. It's going to be a really interesting conversation about what we can see coming in the network space and how things might change in the next few years. Enjoy. Okay, welcome to the show, Khalid. Thank you very much for joining us today.
Thank you.
All right, so Khalid, usually on the show, we have folks give just a brief background of themselves and kind of where they are now and how that role relates to the topic that we're talking about today. But really, your sort of history in the industry, I think, introduces the topic itself. So I wonder if you couldn't give us a little bit of a longer intro than I often get of just your sort of elevator pitch into kind of your history with MPLS, your history going into SD-WAN, and now what you're doing at Graphiant, because that, I think, will help us build the picture of how you came to start Graphiant based on these changes in corporate networking that have been underway since the 20 years ago with the advent of MPLS.
Yeah, so I'm going to date myself, obviously. MPLS is now 20-year technology. If we take a step back, why we went to MPLS? Voice and data were merging. That was the biggest driver for MPLS because you wanted a common infrastructure, which was IP-based, and you needed reliable, scalable, secure infrastructure to connect any to any because of voice and data merging over a single IP infrastructure.
Right.
I was actually luckily part of the team that deployed the first MPLS network ever in the world.
Wow.
So I had the luxury of deploying the first MPLS network. But if you look at it, this data model of converging voice and data had really hit a nerve. MPLS market grew from a zero to a $50 billion market in 10 years.
Right.
Around 2009, 2010, it started to become very clear to me that if you look at what MPLS provided, ubiquitous connectivity, the enterprises were looking for more bandwidth. There were applications that were more bandwidth hungry. Video was the big driver. Office 365 was another very major driver for more bandwidth consumption in the branch. I remember having a conversation with a CIO of a company saying, wait a minute, if I want 10 meg to my branch, I have to pay $800 a month.
Yeah, absolutely. And I'll just back up what you're saying really quickly, because this is one thing we look at Telegeography, that it is still the case. In 2022, our survey demonstrated that the typical MPLS port size is 20 to 50 megs, which obviously is, I mean, it's less than we all have at home, right? I'm sure it's that is still the case, even with MPLS prices having fallen, over those past 20 years. Yeah.
And that whole argument of you need to give me the ability to bring commodity internet to my branch to offset this bandwidth growth.
Hmm.
And this is where I started to evangelize this concept inside of Cisco, saying, guys, we need to figure out to give the ability for an enterprise to get commodity internet into the location and give them the flexibility to connect to the corporate network. So to offset the bandwidth growth, enterprises started to look towards SD-WAN. And the way, the idea of SD-WAN that initially we went out with, that we should be able to use any bandwidth. And the second issue with MPLS, which enterprises still struggle with, is the service providers has the policy control. Anytime I want to make a change, I have to get the service provider involved. On the other hand, with SD-WAN, and the enterprise got the ability to change the policies by themselves. So got the commodity bandwidth, got the policy control, and the third thing was application visibility. It went inside of the MPLS network. I lost the application visibility. Now I wanted the application visibility. These were the three drivers of SD-WAN.
Right.
Now, fast forward to 2017, this is when I started to realize, okay, we have solved the problem of getting the bandwidth, getting the policy control, and getting application visibility, but the data center just got wide open. You don't have two data centers, you have arbitrary centers of data. Your data can be spun up, data center can be spun up anywhere inside of a cloud location. So now all of a sudden, the technologies we've been building for fixed topologies is changing to arbitrary connections. I don't have control of the user. Now I don't have control of my workloads either. So how do you build this connectivity? All the traditional connectivity, if I wanted to use the internet, obviously I need to provide that level of security, and IPsec is the right way we've been doing for 20, 30 years over at layer 3. Now, all of a sudden, if I want to build that connectivity, I have a tunnel sprawl problem. I'll get into an n squared tunnel connectivity, which I can't control. On top of it, the benefit of MPLS was I had ubiquitous any-to-any connectivity, which SD-WAN wasn't providing because of tunnel scale problem. Now, how do I solve the problem of giving that complete tunnel scale, eliminating tunnel scale problem, and giving you the ability to use any-to-any connections? If you look at a typical enterprise today, enterprise is running a mix of corporate cloud applications and providing that service to a really dispersed set of users.
Mm-hmm.
You don't own all the assets. You don't know where the node will spin up. Your connections spin up and spin down all the time. And the underlay infrastructure of the internet is not in your control. So you might put data traffic on a path for which you don't even control end to end. So it becomes
Right.
a very interesting situation for an enterprise that really requires reliability, guarantees security on top of visibility. So this is when I started to think we need to evolve this architecture further. And I'm a protocol guy throughout my career. And you look at all the traditional protocols we had created for predictable fixed topologies. I knew where everything was. All of a sudden, it's not fixed to predictable topologies anymore. And this is where the idea of Graphiant started to come in and says, we need to relook at how we've been building the networking for the past 30 years. It's time to change towards the protocols to innovate in that space. And that's essentially what Graphiant is saying. We need few things. We need to combine the reliability, scale, security, and flexibility of MPLS, any-to-any connectivity, ubiquitous connectivity. But we also need the agility and the speed of SD-WAN. So enterprise can get the policy back, but don't get the complexity. Because when they were in MPLS, they got a single connection into a carrier, which is a BGP peer, and everything was ubiquitously accessible. In SD-WAN, I got my routing back. Great, I got the policy back, but I own the routing. What I learned during Viptela days, people have lost the talent that understands complex routing systems. And we can't hand it over to people who don't understand the depth of how these complex routing systems will be built. So we need to build in technology, we need to innovate all over again. And from my perspective, they needed to do two things. One, first, we need to give a private network. So that means you have scalability, reliability, and privacy that you need. And in today's world, with the carrier neutral facilities that are available, it's very simple to build around them.
Mm-hmm.
Now, the second piece is it has to be as a service.
Right.
People don't have the capabilities and the IT staff to understand these complex network. So as a service, and it has to be cost effective. It has happened to every other aspect of our systems. Compute is as a service, storage is as a service, networks are still built on a bespoke basis
Mm-hmm.
by enterprise and all the SD-WAN vendors. So
Mm-hmm.
that drove me to Graphiant, and that's
Mm-hmm.
what Graphiant is solving. That solve protocol problems, that solve technology. We can't automate our way out of it.
It's really interesting that you say that you were having founded Viptela, sort of back at Cisco. I take it at that time. This is 2017 when you're having these ideas. 2020 comes along and makes all of this, it seems to me, a lot more true than it even had been previously, right? That the you said the n exponentials of the nodes on the network and all of the tunnels, all of that expanded greatly. When remote work went from 3% of the workforce to 40 or 50 or percent or whatever it is, even landing on it now. And also during that time, it seems there's been a greater need for bandwidth as everyone goes back to the office. They still get on web-based UCs and everything that they everyone has replaced the PBX closet with tools like we're using right now, right? And then also the cloud migration accelerated during the pandemic, and I think got a little bit more complicated too, because there's also been a little bit of a cloud sort of push back to the edge when they realized certain applications weren't working so well with the cloud latencies and all that. It seems to me that all the changes, the point is, even since just the last 2 or 3 years, really work out to make this more necessary than it might have even been in 2017, 2018, when everyone was at that point just wrapping their heads around SD-WAN, really, right? So
Yeah, 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 yeah. And to me, the most interesting piece is we are in a data sharing economy. And as more and more data sharing grows, look at what we did to the internet in the last 2 decades. We made internet as a pure client server model. Internet was a peer-to-peer technology. And to preserve the IPv4 infrastructure, we just converted it into client server. Well, guess what? Edge compute is reminding us, let's go back to the fundamentals, make it peer-to-peer. How
right.
do you do? And peer-to-peer B2B exchange would be such a big thing as we start to look in the next 3 to 5 years. The businesses that are generating data, the business that are creating data at the edge would rather have it serviced at the edge rather than backhauling.
Mm-hmm.
Because if you look at it, compute is and storage is way cheaper than the bandwidth.
Right.
Now,
Right.
if I look at that way, if I backhaul that data to the cloud, I create latency problem. I create cost problem because the data between the two business partners will exit twice from the cloud. So how do you get that economics going where you make it peer to peer without telling enterprise to completely address their infrastructure?
Mm-hmm. Mm-hmm. Yeah, absolutely. All right, so I think that's a great intro, but I want to dig in a little bit more on exactly what Graphiant is doing. So if you could maybe give us an overview of kind of maybe what your without visuals here, what your network model looks like in terms of, and also, is this a software solution? Is this a hardware solution? Is it a mix of the two? Kind of bring us through, having queued up that this is a NaaS kind of service. What exactly would enterprises or carriers who are serving enterprises be purchasing from you, if that makes sense?
So Graphian at the core of this consists of three major components. One is the cloud, which is a multi-tenant cloud orchestration operation system.
Mm-hmm.
Second is the stateless core we are building.
Mm.
The stateless core carries zero customer routes, zero encryption keys, zero decryption, and still provides you encrypted transit through this stateless core.
So if I could interrupt just for a second, just because this is telegeography explains the internet, well, I always want to make sure that everybody listening is on the same page. So by stateless core, you mean it's not, I assume, like storing any of those data in a traditional networking sense. Is that right? The right sense of that word?
Yeah, that's very close. It's close enough.
Yeah,
What
sure.
I
Yeah. Well, then please feel free to explain. So that our audience is somewhat technical, but always want to make sure terms like that are agreed upon, if that makes sense.
So if you look at what MPLS VPNs did, MPLS
Hmm.
VPNs carried the customer routing inside of the middle mile of the service provider. So
Right.
every VRF you were creating on a per customer basis, you're creating that routing entries. What Graphiant is essentially trying to say is, okay, guys, SDN came to do state abstraction. If I can abstract all those routes from my core, which is just a transit core, and put it in the off-path controller, I
Hmm.
can carry hundreds of thousands of
Hmm.
customers on the same core, because
Hmm.
now I'm not carrying customer data. I am carrying metadata tags to identify and transport customer data between any locations, anywhere to anywhere. So
Right.
I remove the routing information. Now, on top of it, what the current model, most SD-WAN vendors are doing, they're spinning up their software license as a VNF in a middle mile and doing it on a per customer basis.
Hmm.
I tell people, please ask somebody who's built MPLS network, and they'll tell you it was the VRF scale that after a point became a nightmare for the service provider and also for the networking vendors. You're simply replacing a VRF with a VNF and
Hmm.
expect it to work and scale on a commodity hardware. Good luck, my friends.
Right. Right. Right.
So one of the things that we do is we do completely remove the routing state in the middle. So my device is just a forwarding device.
Hmm.
Second thing also, since you're using internet last mile, you always want to encrypt over the internet last mile. And then you do a decryption, you do re-encryption, you decrypt, route lookup, and re-encrypt, and then forward it to the next hop.
Hmm.
These three operations will hit your performance so badly, it's not sustainable. It's
Hmm.
serious hit to your performance. Decryption, re-encryption, route lookup is not sustainable. So essentially what Graphian does in that sense, we don't decrypt in the middle mile. We don't do route lookups in the middle mile. We create this stateless code that is used to forwarding traffic. And
Hmm.
that will give us orders of magnitude of scale and performance that has never been seen.
All right, so Khalid, we hit the core of the network there, but I wonder if we could focus back on part of that question, which was the way the customer is interacting is with like SD-WAN could come as a device, could come as software. Are you looking at software, hardware, none of the above? Or what is the solution that customers are buying?
So the customers are purely buying a service. We
Hmm.
neither sell hardware, we don't sell software. We sell you capacity on our backbone.
Hmm.
That's significantly different than what traditional SD-WAN and the feature-based systems have done. So
Right.
the third piece of our solution, the cloud, the stateless core, and the edge. So
Hmm.
edge is where the all SD-WAN vendors and all traditional networking vendors have said. We don't, you can get our solution on a commodity hardware, you can run it as a software, as a VM,
Hmm.
and you get service on our stateless core.
Right.
So from our perspective, it's a service. It's neither hardware or software that we're selling. We're selling you a service.
And so I assume then customers are interacting with it through a portal. You have a login, you spin something up, so to speak. But in this case, we're spinning up network, not servers or whatever, right?
Yes, so they go to our cloud portal,
Mm-hmm.
they connect their device, and they decide their policies. If you look at traditional networking, you have to first figure out how your routing will work, figure out how the routing scale will happen. In Graphian's cases, you just simply come to our stateless core and program that stateless core and the way you want to consume. We will do to networking what cloud guys did to compute.
Hmm. Hmm.
You will come and program our network using our cloud portal, which is completely programmable fabric. Don't need to figure out how your routing will work. Don't need to figure out how next hops will process. It simply gives you the policy, gives you the visibility, and says, I I want to connect site A to site B, and this is the policies, this is the QoS I need. Here's a
Hmm.
very interesting piece. Look at in the current times of GDPR. You can say that, okay, if I am in a certain location, I don't want my data to exit Germany. It needs to remain in Germany. Although the shortest path might be through Poland, but
Hmm.
I want this to take a German path. Traditional networking, you can do it because it's destination based.
Right.
By creating this stateless metadata based core, I can give you alternate paths, and based on that, you can decide. So, all this complexity of traditional networking that people have to build, source based design, we do away with all of that. That's
Hmm.
why we need to evolve these protocols, which we haven't in the past 30 years. We can't automate our way out of this. whole situations that we have gotten ourselves into.
Hmm. Yeah, that's really interesting. So just a telegeography, obviously, what we do, everybody knows, submarine cable maps and stuff. We're very focused on layers one, two, three. So this may be a layer beneath what you're used to talking about and focused on. But does that mean you're building backbones of wavelengths across the world? So does Graphiant own a network, or is this a sort of all automation based on SDN and that sort of thing?
The Graphian owns the network. Our
Hmm.
stateless core is built on
Gotcha.
uh, Equinix, digital reality, those locations, and then we
Mm-hmm.
buy circuits from the service providers and connect our stateless core.
Gotcha. So then there is a sort of geographic component. I assume this is a global service. You've rolled out network all over the world, that sort of thing.
Yeah, so we are rolling out our network initially in the United States, but
Hmm.
we have
Hmm.
every plan to take it global. And
Got
in
it.
today's day and time, it's much easier to take it global. I mean, one of the interesting services we are looking at is Equinix's bare metal as a service.
Hmm. Hmm.
So we should be able to spin up a POP very, very quickly if the need arises for our customer to say, I want to expand into Singapore. It should take us a few months to spin it up in Singapore. As long as I get a peering and I get a bare metal as a service, I can spin up a POP. That's the
Yeah.
beauty of the architecture that we're building. Because remember, it's just a forwarding site for us. It's not
Hmm.
carrying customer information. So it's also zero touch. It comes up, the POP comes up, it connects, and the peering happens. And all of a sudden, all the control plane has intelligence. This is just a forwarding device. So from that perspective, protocol innovation gives you so much flexibility that traditional automation can't.
Hmm. Hmm. No, that's that. I think that's particularly interesting because we talk a lot on the show about automation. Usually, honestly, from either the carrier standpoint, so strictly the wholesale kind of world, like Equinix, Fabric, and those kinds of things, or from the more geared towards enterprise. And I'll get to this question later on other NaaS solutions that are out there. But it seems like your solution is there at the right time. Again, going back to my previous theme, with also these capabilities on layers one, two, and three being there on the carrier and data center end, that sort of as you go down to that wholesale layer, they're now more capable of sort of automating service and getting it spun up really quickly as well. So all right, so Khalid, I think we've got a good, decent understanding now of kind of what it is that Graphiant is doing. One thing I'd like to focus in a little bit on is just the sort of the specific go to market strategy in terms of how users interact with your service. Is this a hardware solution, a software solution? Is it kind of neither of those things? In other words, sort of what exactly are folks buying from you, and how does that work for them?
So Graphian is neither a hardware solution nor a software solution. Graphian is pure service. Just think
Hmm.
about it, what cloud guys did to compute. You consume service on the compute. That's exactly what Graphian Backbone will do. You can subscribe to our bandwidth, utilize it. There's no feature tier. You simply consume service from Graphian Backbone. And you were
Hmm.
able to orchestrate a part of our cloud. You can download our software at the edge, and the whole system works end to end.
Got it. That makes sense. Excellent. All right. Well, in that case, I think it really kind of brings me to the next sort of major area that I wanted to talk about, which is network as a service out there for the enterprise. We've talked about that a lot on the show. How about first we start though, kind of on the carrier side, if that makes sense. Where there's been a lot of focus on SDN and automation and what happens at that kind of transport level. Um, what is your general opinion about sort of what has been done in the automation area, and how might that be different from how you're approaching it at Graphiant?
So I will break this into two pieces from the current existing solution point of view.
Hmm.
From a service provider point of view, people like me who have done a lot of work on MPLS VPNs realize the way the solution has been solved today is not sustainable. Every customer has to spin up inside of a carrier backbone a VNF, their VNF of a software license of an SD-WAN vendor, and run as a bespoke network.
Right.
So somebody who's played his life in MPLS VPNs, VRFs became unsustainable and it became a scale problem. You think you can use commodity compute, spin up a VNF on a customer by customer basis in the middle mile and scale it? That's not sustainable. So from that point of view, if you stay on a software license base on a bespoke customer basis, it's not going to survive. Look at the
Mm-hmm.
beauty of internet. Transit never had a lot of state. That's why internet scaled to the orders of magnitude. We're trying to bring state of a customer on a software license and expect it to scale. That's not sustainable. This is why I always keep on saying there comes a time where automation reaches its limit. Innovation needs to happen. And the only way innovation needs to happen is in the protocol. Protocol
Mm-hmm.
stacks needs to evolve. Otherwise, we will be stuck. I mean, I love a quote from Bill Gates. He said, automation done to an efficient system increases efficiency, and automation done to an inefficient system increases inefficiency. We're reaching a point of inefficiency. We
Mm-hmm.
need to innovate. We can't automate our way out of it. Second piece is if I look at a traditional MPLS carrier, this is where that's very interesting. I'm going to tie it back to a VRF discussion. You take an MPLS carrier who has, say, about 100 POPs. Each POP is serving about 100 customers, and out of which each VRF has 30 to 40 lines of config. For redundancy, if you do this math, the service provider has about 700,000 lines of distinct configuration. With Graphiant architecture, you have 100 POPs. The router that sits is zero touch, just 4 lines of config, and you can bring all your customers up. Whether you have 100 customers or 100,000 customers on a Graphian backbone, the stateless core, you have 4 lines of config always. That's the orders of magnitude change we're bringing, or even from a service provider perspective. So the architecture is designed to scale for the future of our industry, which is heading towards distributed, unpredictable topology, which might be hub and spoke, might be partially mesh, might be peer to peer. And that's what we're doing. We're solving a technology problem, not automating.
Mm-hmm. Gotcha. So maybe this is too high level and simple of a way to put it, but in a sense, if automation is taking any process that gets repeated and taking it out of human hands, you just want to get rid of that process rather than automate it, essentially.
Yes, let the protocols negotiate and the system should work.
Mm-hmm. Absolutely. All right. So keeping on then with the sort of network as a service theme, like I mentioned previously, we've talked a lot on the show about the NaaS services that are out there available to the enterprise. Now, the fabric kind of providers, Packet Fabric, Megaport, that kind of thing. Is your service going to be sort of competitive with that service, complementary to it? How does it play into the existing NaaS services that folks may be somewhat familiar with out there now?
So we would be very, very complementary to them. In fact, we are
Mm-hmm.
talking to Packet Fabric as possible partnership.
Mm-hmm.
Packet Fabric provides circuits, guaranteed delivery. You will be able to spin up these connections at pay-as-you-go bandwidth model. We will bring the whole layer 3 architecture. Think about it. Packet Fabric is an alternative to great layer 2 VPNs. We will be the alternatives for layer 3 VPNs. So together,
Mm-hmm.
they provide transport, they provide connectivity, we provide the layer 3 infrastructure. From an enterprise perspective, they don't have to build complex routed system. They don't have to worry about cloud on-ramps. They just come to our fabric and everything works, whether connecting to cloud, whether connecting to data center, whether connecting to colo, whether connecting to edge, whether connecting B2B. That's another very, very interesting space nobody actually talks about. The growth of B2B partners,
Mm-hmm.
partnership that data exchanges will happen. And from Graphian's perspective, Packet Fabric is an ideal partner for me. I can use their capacity, I can use their transport. They have an availability anywhere I want to go. So if I combine the best of the platform as a service from Equinix, circuit capacity capability from Packet Fabric, and the layer 3 transport infrastructure from Graphian, that's a perfect solution for the modern day connectivity that is required by the enterprise.
Absolutely. Yeah, that makes a lot of sense. And just one little sort of follow-on question to that. Would you also work with directly with kind of MSPs who, sort of might put a whole package like that together for the enterprise. I hear more and more from enterprises who, with all of these new skills that are needed to run these kinds of services, have gone much more in the outsourcing direction than they used to. Of course, yours is a simple solution, but is this something that could wrap into what MSPs are putting together for enterprises that want to kind of take their hands out of a lot of this?
Absolutely. I mean, in phase one of our strategy for even service providers, MSPs will have the ability to offer our service to their customer. They
Hmm.
want the full managed service provided to the customer. Graphian portal is available. They can use their existing tool to integrate with us through APIs and offer services to their customer. We provide them the backbone that they didn't have. And in
Right.
certain cases, if you're a regional player, you don't have a presence. We'll provide you the ability to go and manage service and bid for a customer, which requires a nationwide or in future global presence. So, from the managed service provider's perspective, they manage and run. We provide them tools and infrastructure to operate the network.
Hmm. Absolutely. All right. Now we can't have a conversation about WAN these days really without having to bring in the security piece, especially SASE, because everyone still wants to wrap their heads around exactly what that means and what the implication for their network strategy is. It's now no longer can you roll out a network and then security works on that network, but now security has to be the forethought on what should my network look like. So is SASE a part of your plan in terms of how you present this product to the enterprise, or is it something that you can easily integrate using other vendors and that kind of thing?
Ideally, I believe that we will be the partner that as SSE players should look at. We would be the
Mm-hmm.
A. One of my colleagues has a brilliant analogy which says, "In SASE, A is silent." Well, we want to be that A who solves that problem. You
Right.
would be able to provide access connectivity at a scale. Why are SASE players wasting so much amount of compute on just simple tunnel terminations?
Mm-hmm.
Why are
Mm-hmm.
they doing route lookups? We can solve that problems for them. So within that direction, we're creating a gateway that will peer with all SSE players. So an SSE player doesn't need to build 5,000 tunnels for a 5,000 branch network. They
Mm-hmm.
have a single peer into Graphian. They handle security. We handle connectivity. So rather than building their physical infrastructures and POPs and creating a complex network, we want to be their network and let
Mm-hmm.
them do the security. So Graphiant is a great solution or a partner for an SSE player who's trying to build this whole POP distributed infrastructure and handle all the tunnels, routing, complexity of decryption. We want to give them the ability to do decrypt at their level. We just provide them a transit path of scalable solution. So think about this: an SSE player has supporting a customer on 5,000 locations instead of 5,000 tunnels. They have two into our backbone for redundancy, and all their 5,000 tunnels are handed through our transit. So
Mm-hmm.
they do security and they can spin it up on demand if they feel that they need to intercept at another location rather than fixed location. So we'll give them that ability because our transport is stateless. They can program the transport they want to, and they can change topologies on demand based on the needs of the customer. That's why I keep on saying time has come for us, the protocol guys, to look at this problem differently than what the way we have been solving for the past 30 years.
Right. Right. Yeah. So if I understand you correctly, then is it the case that you might have some channel partners and that might come to fruition in the future, but also that the consumer of your service could really bring their own SSE providers and their own stack, and it would you would just be providing the access bit, and but more to the point, maybe simplifying the rest of that security stack for their provider.
Exactly. We will pair with their provider, and then it just becomes our solution offering. So we will take them to their provider rather than worrying about how many tunnels and how do I scale those
Mhm.
tunnels.
Excellent. All right. Well, Khalid, we've talked a lot about a lot. I think there's a lot to absorb here, just in terms of what you're doing. Although at the core, it still seems pretty simple. in the sense of what it will mean for your potential customers. But kind of want to get your take now, having been through that MPLS and SD-WAN revolution and seeing how those impacted the way folks thought about how to organize your WAN. What is your vision for what the WAN becomes in the next, say, 3 to 5 years?
I think WAN is going through some very interesting transitions. The first phase was cloud adoption. Everybody's rushed towards the cloud. The second phase is the edge market.
Mm-hmm.
Much more data is created. If you look at very simply, I mean, I was reading some numbers. I think that's published by Gartner or IDC. I might be confused. I think it's
Mm-hmm.
IDC. As of today, there is 113 zettabytes of data, while we have 786 terabytes in the bandwidth.
Wow, that's a really interesting statistic. Yeah, we need to fix that ratio. It's
So if we transferred all data today, it's going to take us 36 years.
Mhm.
Now, looking at 2025, there will be 175 zettabytes of data, while we will have 1.68 petabytes of bandwidth.
Mhm.
So the point I'm trying to make here is the way the future is going to adopt is compute is cheaper, storage is cheaper. It's going to
Mhm.
get more towards the edge. Service
Right.
providers will build infrastructures where they will put their infrastructure closest to the last mile and start providing that service out of those locations.
Mhm.
Those locations I see being transformed more into a B2B market. Anybody who's generating at the edge, somebody wants to consume and monetize that data. If that data monetization happens between two entities, you can't backhaul that data. You
Mhm.
simply can't backhaul that data. The transactions will happen more peer to peer. So, hence, this whole infrastructure, which is about edge computing, third party data monetization, is very centered around peer to peer data exchanges. And this is where I see this whole ecosystem evolving. And I think that's a tremendous opportunity for enterprises to figure out how to change their business model. Anybody who's creating a device will sell that as a service rather than a product.
Mhm.
And anybody who's consuming it will say, okay, I'll give you access to my device and data. I need a piece of that monetization. So I can, same way predictive analytics will happen, that I have access to my data. I can predict when my machine will fail. So more and more we're heading towards a service economy. The future of internet belongs a lot more to enterprise than to the consumers. And
Mhm.
that data growth that we're seeing happening is going to be much more driven by business to business transactions rather than a consumer watching Netflix. So I see a
Yeah.
tremendous growth for the future of the internet, the future of connectivity, and really exciting times for everybody in this ecosystem.
Yeah, that's really interesting because it really has been the case that enterprise has tended to lag with the consumer technologies. But you're saying that we might see that kind of flip where enterprise is the real sort of driver of advances here rather than, for example, unified communications, right? We were all doing Skype calls in 2005, long before it was an enterprise ready tool. But now we have the opportunity with pushing all these things to the edge, like you said, more B2B applications and data exchanges of that innovation happening between and for enterprises rather than kind of lagging what we do for the eyeballs, essentially.
Because this is something that I like to say to the industries. We're heading towards the industrialization of the internet. Today,
Mm-hmm.
internet is a more consumer medium. Tomorrow's internet is more industrial medium. It's truly the industrialization of the internet. Because just think about it: the data that's generated at the edge, it might be somebody's healthcare data.
Mm-hmm.
It might be a factory floor data that requires privacy guarantees. In certain cases, certain path. It's a financial data, so for GDPR requirement, it can't leave the country. All of those requirements, the network has to respond to it. So I had this conversation with one of the CTOs of BT. He said something very, very interesting. Everybody for decade has tried to build net application aware networks. It should be the other way around. Applications should become more network aware than
Mm-hmm.
network being application aware. If
Mm-hmm.
application knows what the network is capable of doing, application can program the network the way it wants to consume it. Here's the latency, here's the delay. It might be a PCI compliant path, it might be a HIPAA compliant path, it might be a GDPR compliant path.
Mm-hmm.
If those characteristics are published to the application, and application is servicing and starting at the edge, it's an ideal scenario for network becoming very relevant and application programming the way they actually want to consume the network rather than network making decisions at every hop.
Mm-hmm. No, that's really interesting. I think that is going to be really fun to watch of sort of turning on its head of what the network is, and I think in particular from telegeography perspective, we're looking at sort of the coming up from the transport layer. That all has to be there. But it used to be that was the story of the network. Now the story of the network in terms of how folks are consuming it on the enterprise side is going to be much further up the stack, right? And so while the transport layer has to be there, it has to be reliable still. It's really about taking that kind of almost in a way like we've avoided in the past, saying, "Oh, the network is a given," right? And pushing it onto the software, the applications, all that kind of thing. I think that's going to be really interesting to watch. And in a sense, the dissolution of the WAN, making it more useful for the enterprise in a sense, right? So,
yes, exactly.
Excellent. Well, I think this has been really interesting, and I'm personally excited to kind of keep up with how this all develops. Khalid, for listeners out there who want to follow along with what you're doing at Graphiant and how things are developing in this way, how could they keep up with you and your work?
So come and visit our website, graphiant.com. There's a lot of good content. There's a lot of good discussion. There's a lot of good information. Or follow me at LinkedIn.
Mm-hmm.
I publish a lot of my work on LinkedIn.
I think that's great. I think more and more we're seeing that folks using LinkedIn in a kind of way of rather than just more marketing kind of things of exchanging ideas. And I'm really, as an analyst, excited about that because it's a much easier, frictionless place to follow that kind of thing than going to particular blogs or Twitter or something like that. So. But I hope we can catch up and talk again sometime soon.
I would love to talk to you again. Thank you very much for your time.
Excellent. Cheers. Thanks for listening. Telegeography Explains the Internet comes from the experts here at Telegeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.